Hello, friends. Take a quick look at the device you're watching this video on right now. Whether it's a phone, a laptop, a desktop, or a tablet, it's a computer system. And in this video, we're going to break down exactly what that means. What actually counts as a computer system? What are the pieces that make it work? And how do those pieces talk to each other to do everything from playing this video to running an entire business? Let's start from the ground up. All right, let's define it properly. A computer system is a combination of hardware, software, and data, all working together to do four basic things: accept input, process it, store it, and produce output. That's really the whole job. You give it something, a tap, a click, a voice command, a file. It does something with that information. It remembers what it needs to remember, and it gives you back a result you can actually use. Every computer you've ever touched, from a smartwatch to a supercomputer, follows this exact same loop: input, process, store, output. Now let's look at what's actually doing the work behind that loop. A computer system stands on three pillars: hardware, software, and data. Take any one of them away, and the whole thing falls apart. Hardware is the physical stuff, the parts you can actually touch: the CPU, the RAM, the storage drive, the keyboard, the screen, the cables inside. If you can drop it on your foot, it's hardware. Software is the set of instructions that tells the hardware what to do. Your operating system, like Windows, macOS, or Android, is software. So is every app you open, every browser tab, every game. Hardware without software is just an expensive paperweight. And data is the information you're working with: your photos, your documents, your messages, the video you're watching right now. Software processes data. Hardware stores and moves it. Hardware, software, data. They only matter when they work together. Let's zoom into the hardware first and see what's really inside that box. Let's break hardware down into the parts that actually matter. Inside any computer, you'll find roughly 6 categories of hardware doing the heavy lifting. First, the CPU, the central processing unit. This is the brain of the machine. It executes instructions, does calculations, makes decisions. Every single thing your computer does ultimately runs through here. Then there's RAM, random access memory. Think of RAM as your computer's short-term working memory. When you open Chrome with 20 tabs, all those tabs live in RAM, so the CPU can access them instantly. The catch? RAM is wiped clean the moment you turn the computer off. That's where storage comes in: your SSD or hard drive. This is long-term memory. Your files, your photos, your operating system itself, all stored here permanently, even when the power is off. Input devices: keyboard, mouse, microphone, touchscreen, are how you talk to the computer. Output devices: monitor, speakers, printer, are how the computer talks back. And tying all of this together is the motherboard. It's the big circuit board that everything plugs into, with tiny copper traces letting all these components communicate. Now, hardware is only half the story. Let's look at the software that brings it all to life. Software isn't just one thing. It actually comes in layers, and each layer sits on top of the one below it. At the top, you have application software. This is everything you actually open and use: your browser, your music app, your chat apps, your games, the video player running this video. Apps are what most people picture when they hear the word software. But apps can't run on raw hardware directly. They need a manager underneath them, and that's the system software, mainly your operating system. Windows, macOS, Linux, Android, iOS, these are all operating systems. They handle the hard stuff: managing memory, scheduling which app gets the CPU's attention, organizing files, dealing with security. Without an OS, every app would have to know how to talk to every piece of hardware on its own. That would be chaos. And then below the operating system, you have firmware and drivers: small, specialized programs that know exactly how to communicate with specific pieces of hardware. Your graphics card has a driver. Your printer has one. Your keyboard has one. They're the translators between the OS and the silicon. So when you click a button in an app, that click travels down through these layers. app to operating system to driver to hardware, and the response travels back up the same path every single time. Now we've covered hardware and software. Let's talk about the third pillar, data. Now the third pillar, data. And here's the wild part. No matter what form data takes on the surface, underneath it's all the same thing. Text messages, photos, songs, videos, spreadsheets, this video right here. To a computer, every single one of these is just a long sequence of zeros and ones, binary. That's the only language the hardware actually understands. When you type a letter, the keyboard converts that key press into binary. When you take a photo, every pixel's color becomes a number, and that number becomes binary. When the computer plays you a song, it's reading binary off your storage drive and converting it back into sound waves your speakers can produce. And data doesn't just sit there. It moves through a life cycle. It gets captured from somewhere, processed by the CPU, stored on the drive, and retrieved when you need it again. Then the cycle repeats. Every app you use is really just doing some version of this loop on different kinds of data. So now we have all three pieces: hardware, software, data. Let's see how they actually work together when you do something as simple as opening a file.
Let's tie this all together with something you've done 1,000 times: opening a document on your computer. Step 1, input. You double-click the file. That click is captured by the mouse and sent to the computer as an electrical signal. Step 2, software takes over. The operating system sees the click, figures out which file you tapped, and tells the right application, say your word processor, to open it. Step 3, the file lives on your storage drive. The OS sends a request to the SSD or hard drive to go find that specific file and read it. Step 4, this is where the action really happens. The file gets loaded from storage into RAM, because RAM is much, much faster for the CPU to access. Then the CPU starts processing the data, decoding the format, laying out the text, applying the fonts and styles. Step 5, output. The processed result is sent to your monitor, and the document appears on your screen. All 5 steps, input, software handoff, storage read, CPU processing, output, happen in milliseconds. Hardware, software, and data, all working in perfect coordination every single time. Now, let's quickly look at the different types of computer systems you'll actually encounter in the real world. When most people hear computer, they picture a laptop. But computers come in a much wider range than that, and they all follow the same rules we just covered. On the smallest end, you have embedded systems. These are tiny computers built into everyday objects: your smartwatch, your car's engine controller, your washing machine, your smart TV. They usually do one specific job and do it well. Next up, mobile devices. Your smartphone and tablet are full computer systems in your pocket. They have a CPU, RAM, storage, an operating system, and apps, just shrunk down to fit in your hand. Then you have personal computers, laptops and desktops. These are the general-purpose machines most of us use for work, study, and entertainment. Step up from there, and you reach servers. These are computers built to serve other computers. Every website you visit, every cloud app, every video on YouTube, there's a server somewhere handling that request. They're optimized for reliability and running 24/7. And at the very top, supercomputers. These are massive systems built for heavy scientific work: weather forecasting, drug discovery, training large AI models. They're not really one computer. They're thousands of processors working together as one. Different sizes, different purposes, but the same fundamental design: hardware, software, data working together. Let's wrap up with a quick recap. Let's quickly bring it all home. A computer system is built on 3 pillars: hardware, the physical machine; software, the instructions that run on it; and data, the information it works with. And no matter what kind of computer you're looking at, a smartwatch, a phone, a laptop, or a giant server, they all follow the same simple loop: input, process, store, output. Once you see this pattern, you start noticing it everywhere. The phone in your pocket and a Google data center are honestly running on the same fundamental ideas, just at very different scales. If this helped things click, hit that like button,
Subscribe to Compyra for more videos like this, and drop a comment if there's a topic you want me to break down next. Thanks for watching, and I'll see you in the next one.